Welcome again. Today we look at the determination of the relative amounts of products formed during the electrolytic process. As we look specifically at this question, to calculate the mass in grams of copper produced at the cathode when a current of 1.50 amps is passed through an aqueous solution of copper-2 sulfate for 3.25 hours. First, it is useful to visualize what this looks like. And here would be our aqueous solution of copper-2 sulfate connected to copper electrodes. As the current goes through this circuit, we have the electrolytic process occurring. And as the cathode is negatively charged, copper ions from solution would receive those electrons and in so doing be reduced to copper and then be deposited at the cathode. And this forms the basis of the process of electroplating. But to determine the actual amount of copper that is deposited, it is first necessary to quantify the amount of charge in the system. And to do this, we multiply the time in seconds by the current in amps to get an answer in coulombs. And then we note that 1 Faraday equals 96,500 coulombs per mole. In the electrolytic process, 1 Faraday is able to discharge 1 mole of an ion. With this information available, then we multiply the current of 1.50 amps by the time in hours, noting that 60 minutes make up 1 hour and 60 seconds make up 1 minute. We multiply twice by 60 to get a value of 17,550 coulombs charge in this system. Given that 1 Faraday discharges 1 mole of electrons, then 17,550 out of this 96,500, which discharges 1 mole, will discharge 0.182 moles. And 2 moles of electrons are required to produce 1 mole of copper. Then it follows that 1 mole of electrons would deposit half a mole of solid copper. That 0.182 of a mole would deposit 0.182 multiplied by 0.5. And this comes to 0.0910 moles of copper. Because the question specifically asks to determine the mass of copper deposited, then we convert moles into mass using this relationship where n, the number of moles, is equal to the mass in grams divided by the molar mass. Rearranging this equation, it follows that the mass deposited would be the number of moles multiplied by the molar mass of copper. And that comes to 5.78 grams, with our answer to 3 significant figures, in keeping with the data provided in the question where the current is given to 3 significant figures and the time in hours given to 3 significant figures.